Hi everyone, welcome back. So GFG problem of the day today is bottom view of binary tree. So in this question what we see is we are given a binary tree. We have to return an array where elements represent the bottom view of the binary tree from left to right. And if there are multiple bottommost nodes for horizontal distance from the root, then the later one in level order traversal is considered. For example, in this tree 3 and 4 are at the same place, so we consider 4, which comes after 3 in level order traversal. Bottom view of the tree is if we view from the bottom what nodes we would see. First we would see 5, then 10, then 4, then 14, then 25. So this is the bottom view. How shall we approach for this question? Moving to the solution part. First of all, we can keep a tree map where we will keep integer, that is the position, the horizontal position of the value, which position it is, and an integer array. In this integer array we would keep the level and the value, that is the data of the node. Now we will do the traversal of the tree using a recursive function. Moving to the function, we have node root, we have int p, that is the position, that is 0 position initially, then this would be -1 position, this would be +1 position, this would be -2 position, this would be 0. That is the horizontal positioning. So that would be stored in p, and int l will be the level, that is 0th level, then first level, then second level. And this is our tree map that will store the position and the integer array for that position. Now if a root is null, that is the base case that we have to return from. Otherwise, if our map contains the position, the horizontal position, if our map contains it, then we will get the array from the map. That array first index will be for the level. Now if the value in the maps that is level, that element's level is less than our current root elements level, or it is equal, then we will just replace it. This means that if our current element level is below the previous element, that is also for bottom, or if it is equal, then we have to keep the latter element, like in this case. Suppose this 8 would have been stored earlier. After that, next elements comes 10. These are on the same horizontal position, but the level for 10 is higher than 8, so we have to keep the higher level. Or if they are on the same level, then we have to keep the later coming element. So for that we check this condition. If our original element's level is less than current element's level or equal, then we have to replace that element for that position p, horizontal position p. We just change it, we keep a new array, data would be our current roots data and L would be current roots level. Otherwise, if this position is coming for the first time, we simply have to keep the root data and its level. For the first time, we just have to keep it. If it is repeating, then we have to check if the current level is higher or equal, then we have to keep the current, otherwise we will keep the previous one as it is. Now we will move for tree traversal root dot left. For left, we will change the horizontal position by -1. Level will always be +1. Then map is the same. For right node, we will move root dot right. Position will go +1. Level will go +1. So after this traversal, our tree map would be having tree map we have used instead of hash map because tree map keeps the keys in sorted order. So all the positions, horizontal positions, will be in sorted order. That would be from the leftmost to the rightmost. Most negative one this side, left side, and most positive one the right side. That would keep it in sorted order. We do not have to do any other thing in that. So we have used tree map. Now for every position we have the last element. That element we just have to add to our answer list. That element's data we have to add to our answer list. So we move for all the keys in the map, and we get the array, and 0th index for every value is the root.data, that's the data of that node. So we add that data to our answer list and finally return the answer list. I hope you guys would have understood the solution. This was the bottom view of binary tree. This is a widely asked question: horizontal view, vertical view, bottom view, right view, left views. These are certain views of the binary trees. This is one of them. This is widely asked question. So I hope you guys would have understood it. Thank you.